Wilde gaan staan. U kunt wel plaatsnemen.
Dear candidate, colleagues, friends, family, and members of the Corona and the Reading Committee and supervisors, I hereby open this academic session in which Willemijn Middag van Spanje will defend her academic thesis entitled Bringing Neglected Space to Light, Understanding and Treating Visual Spatial Attention Deficits with a Non-Invasive Brain Stimulation. I kindly ask you now to give us a summary of your great work. Thanks a lot.
Dank u wel. Hooggeachte prorector, leden van de oppositie, promotoren, collega's, lieve vrienden en familie. Hartelijk dank dat u vandaag hier aanwezig bent, fysiek of online. To all non-Dutch speaking colleagues and close friends joining online from different parts of the world, also thank you for being here and sharing this special moment with me. My 15-minute talk will be in Dutch, but the discussion afterwards will be in English. Het is mij een eer om vandaag mijn proefschrift te mogen verdedigen, getiteld Bringing Neglected Space to Light, Understanding and Treating Visual Spatial Attention Deficits with Non-Invasive Brain Stimulation. Stelt u zich eens voor dat u uw kind helpt bij het zoeken naar een ontbrekend Lego-steentje in een grote berg speelgoed. Dat is al lastig voor u als volwassene misschien nog moeilijker voor een kind. Maar stelt u zich nu eens voor hoe moeilijk die zoektocht zou zijn als uw hersenen niet eens de helft van die berg goed zouden kunnen registreren. Dat is hoe het is voor mensen met visuospatial neglect. Een aandoening die vaak voorkomt na een beroerte. In gezonde hersenen verwerkt de linker hersenhelft doorgaans informatie van de rechter lichaamshelft en omgekeerd, wat geldt voor zowel zintuigelijke als motorische functies. Echter, mensen met neglect merken dingen aan één kant van hun omgeving niet op of reageren er niet op. Ondanks een normaal gezichtsvermogen en ook een gezonde motoriek. Het probleem zit hem dus niet in het zien, maar in de aandacht. Neglect treedt meestal op na een beroerte in de rechter hersenhelft, waardoor mensen de linkerkant van de ruimte negeren. Zo tekenen zij bijvoorbeeld een klok met alle cijfers aan één kant, of eten ze slechts van één helft van hun bord, of scheren ze slechts één kant van hun gezicht. Neglect ontstaat wanneer door hersenschade twee belangrijke aandachtsnetwerken verstoord raken. Een aandachtsnetwerk bestaat uit meerdere hersengebieden die samenwerken om een cognitieve functie mogelijk te maken, zoals geheugen of aandacht. Het dorsale netwerk is betrokken bij endogene of vrijwillige aandacht en helpt om de aandacht doelbewust te richten, doelgericht. Het ventrale netwerk helpt bij het opmerken van onverwachte prikkels. En schade aan deze netwerken, met name aan de parietale gebieden of aan de verbindingen ertussen, kan leiden tot neglect. Het bestuderen van aandacht bij patiënten is lastig. Beroertes kunnen verschillen in grootte en locatie. En patiënten verschillen ook in leeftijd en herstelvermogen. En we kunnen niet meten hoe aandacht voorafgaand aan die beroerte was. Daar komt transcraniële magnetische stimulatie om de hoek kijken. TMS is een niet-invasieve methode waarbij met magnetische pulsen tijdelijk hersenactiviteit wordt beïnvloed. Het is bijvoorbeeld mogelijk om met remmende of inhiberende TMS activiteit te verstoren. En dit type TMS stelt onderzoekers in staat om op een veilige en ook gecontroleerde manier een virtuele lesie te creëren en zo te onderzoeken ook hoe aandacht werkt. In de afgelopen decennia is remmende TMS over de parietale gebieden ook vaak gebruikt om neglectachtige symptomen op te wekken bij gezonde proefpersonen. En om de effecten van TMS op aandacht te meten, gebruiken we computertaken, waarin deelnemers reageren op visuele aanwijzingen, ofwel cues, die voorspellen waar een doelstimulus zal verschijnen. En een doelstimulus is bijvoorbeeld een pijl aan de linker of de rechterkant van het scherm. En in deze taak moeten participanten zo snel mogelijk aangeven of de pijl naar boven of naar beneden wijst. Nou, wanneer cues dus correct zijn, reageren mensen sneller wanneer de pijl verschijnt dan wanneer de cues misleidend zijn. En dit laat zien dat het verplaatsen of het oriënteren van de ruimtelijke aandacht de verwerking van visuele informatie versnelt. Maar aandacht gaat over meer dan alleen ruimtelijke oriëntatie. Het omvat ook waakzaamheid en executieve controle. Waakzaamheid, of alerting genoemd, gaat over het voorbereid zijn op een stimulus. Dus waakzaamheid kunnen we meten met een neutrale cue die wel aangeeft wanneer, maar niet waar een stimulus zal verschijnen, zoals symbolen die naar beide kanten wijzen. En door reacties met en zonder zo'n cue te vergelijken, meten we het effect van waakzaamheid. Executieve controle helpt ons om afleidingen te negeren en om conflicterende informatie te verwerken. We testen dit door afleiders toe te voegen naast de doelstimulus. Wanneer die afleiders conflicten veroorzaken, reageren mensen trager of minder accuraat. Dit laat zien hoeveel moeite het kost om afleiders te onderdrukken. En eerdere TMS-studies richten zich voornamelijk dus op die oriëntatie, maar negeerden deze twee andere belangrijke aspecten van aandacht. In hoofdstuk 2 vullen we deze lacune aan door te onderzoeken hoe de parietale cortex de aandacht als geheel ondersteunt, inclusief waakzaamheid en executieve controle. Dit deden we door inhiberende of remmende TMS over de rechter parietale cortex toe te dienen en te kijken of dit neglectachtige symptomen kon opwekken bij gezonde proefpersonen. En we verwachten, net als bij een echte lesie in de rechter hersenhelft, een linkzijdig neglect hierdoor. En gebruikten ook weer de computertaak die ik zojuist heb uitgelegd om dit te meten. We vonden effecten op waakzaamheid en op executieve controle die onze hypothese ondersteunen, namelijk neglectachtige symptomen links. Maar we vonden geen effect op die oriëntatie. Dat was verrassend, want eerdere TMS-studies vonden wel oriëntatie-effecten. Naast onderzoekstoepassingen kan hersenstimulatie ook klinisch worden ingezet. Het is niet invasief, veilig en toont ook veelbelovend als een therapie. De idee achter hersenstimulatie na een beroerte is gebaseerd op een theorie die stelt dat de twee hersenhelften elkaar normaal gesproken in balans houden. Wanneer één zijde beschadigd raakt, dan raakt die balans verstoord. De gezonde kant wordt dan overactief en kan de aangedane kant zelfs verder onderdrukken. En om die balans te herstellen kunnen verschillende strategieën worden toegepast. Het kan zijn dat de aangedane zijde wordt gestimuleerd om activiteit daar te verhogen. Of de overactieve gezonde zijde wordt geremd. Of een combinatie van die twee. Deze methoden hebben goede resultaten laten zien bij het herstel van motoriek en bij spraak na een beroerte. Maar bij neglect blijven de effecten tot nu toe beperkt. In ons onderzoek bekeken we een andere vorm van hersenstimulatie als ondersteuning bij herstel na een beroerte. En dat is transcraniële wisselstroomstimulatie, afgekort TACS. In tegenstelling tot andere vormen die gericht zijn op het verhogen of verlagen van activiteit, werkt TACS door het synchroniseren van hersenritmes. Elke hersenfunctie, van aandacht tot beweging, is afhankelijk van bepaalde hersengolven. En door elektrische stroompjes van lage intensiteit met een specifieke frequentie toe te dienen, kan TACS deze golven als het ware meenemen in een nieuw ritme, door te sturen wanneer zenuwcellen vuren. Zo kan communicatie binnen netwerken en taakprocessen worden bevorderd. Om hersenritmes te bestuderen gebruiken we EEG, elektroencefalogram, een methode die hersenactiviteit meet. EEG-onderzoek naar aandacht laat zien dat alfa-golven een belangrijke rol spelen bij aandacht. En alfa-golven zijn hersenritmes die trillen met een frequentie van 10 per seconde. Wanneer we onze aandacht in de ruimte verschuiven, neemt de alfa-activiteit toe in de hersenhelft die ipsilateraal is aan de richting van de aandacht. of af in de contralaterale helft. En onderzoek naar TACS laat zien dat TACS deze hersenritmes dus kan beïnvloeden en daarmee ook dus de ruimtelijke aandacht kan moduleren bij gezonde mensen. Maar dit opent de deur naar het gebruik van TACS als behandeling voor mensen of patiënten met aandachtstoornissen zoals neglect. Zoals in deze onderste figuur ook te zien is met het model in ons achterhoofd, zouden we hypothesegewijs een linkzijdig neglect kunnen compenseren door alpha-power in de linker hersenhelft te verhogen via TACS. In plaats van meteen de behandeling uit te proberen op patiënten, behandelden we eerst die virtuele patiënten die we in hoofdstuk 2 hadden gecreëerd. Dus direct nadat we met TMS tijdelijk een deel van de rechter parietale cortex hadden geremd, pasten we alpha-TACS toe aan de linkerzijde van de hersenen, om de aandacht dus weer terug in balans te brengen. En we maten hersenactiviteit met EEG en gebruikten dezelfde taak om de verschillende aandachtscomponenten te testen. Zoals we net al zagen, had TMS effect op waakzaamheid en executieve controle. Maar gedragsmatig werkte de daaropvolgende TACS echter niet. Deelnemers verbeterden niet. We keken daarom naar de EEG-data. Na TMS zagen we de verwachte verschuiving in hersenactiviteit naar de rechterhemisfeer. Maar toen we vervolgens TACS toepasten op de linker hersenhelft, verschoven de hersenritmes niet terug naar links, wat we wel hadden verwacht. Maar de verwachte verschuiving trad alleen op wanneer mensen geen echte TMS vooraf hadden gekregen. Dus in de hersenen waarin geen TMS, geïnduceerde virtuele lesie, was aangebracht. Het lijkt er dus op dat de eerste hersenstimulatie, de TMS, het brein zodanig veranderde dat het de beoogde werking van de tweede stimulatie, de TACS, tegenwerkte. Dit toont aan dat de reactie van het brein op stimulatie sterk afhangt van de bestaande toestand. In hoofdstukken 4, 5 en 6 onderzochten we of alpha-TACS neglectsymptomen bij echte patiënten kon verminderen. Hoofdstuk 4 beschrijft onze eerste klinische studie bij 16 patiënten in de subacute fase na een beroerte. We pasten stimulatie toe op de onaangedane hersenhelft. Elke patiënt kreeg zowel echte als placebo-stimulatie in 2 afzonderlijke sessies. Aandacht werd gemeten met taken die beter of meer gebruikelijk zijn bij het testen van aandachtsprocessen bij patiënten, namelijk een visuele detectietaak en 2 veelgebruikte pen- en papier-neglecttaken. Bij de detectietaak moeten patiënten aangeven aan welke kant ze de doelstimulus zien verschijnen. In het plaatje is het aan beide kanten. Bij de belstaak moeten alle bellen worden opgezocht te midden van heel veel afleidende andere figuurtjes. En bij de lijn-doorstreeptaak moeten de lijnen worden doorgestreept daar waar de patiënt denkt dat het midden is. Bij de detectietaak en de bellentaak zagen we dat de patiënten na echte stimulatie beter in staat waren om stimuli aan hun verwaarloosde zijde op te merken. Deze verbetering trad niet op na placebo en hield zelfs stand na afloop van de stimulatie. We vonden echter geen effect op de lijn-doorstreeptaak. In hoofdstukken 5 en 6 onderzochten we of het combineren van TACS met standaard revalidatie extra voordelen biedt voor patiënten met chronisch neglect. We testen of meerdere sessies TACS, gecombineerd met scantraining, dat is de reguliere neglectbehandeling, tot grotere verbeteringen in aandacht leiden dan training alleen. 22 patiënten deden mee. Ze werden willekeurig toegewezen aan een echte of een placebo-TACS. En 3 keer per week gedurende 6 weken kregen ze stimulatie en training in 40 minuten durende sessies. We maten hun vooruitgang op meerdere momenten tijdens en na de behandeling. Met functionele maten en ook taken die neglectgedrag in het dagelijks functioneren meten. De belangrijkste uitkomstmaat was een cancellatietaak. Bij deze taak moeten de patiënten zo snel mogelijk de kleine sterren vinden en doorstrepen. We vonden dat patiënten die echte TACS kregen meer vooruitgang boekten in aandacht voor de verwaarloosde zijde dan patiënten met placebo. Deze verbetering zagen we zowel op de cancellatie als de detectietaak en bleef zelfs bestaan tot 3 maanden na de behandeling. We vonden geen effecten op de lijn doorstreep of op dagelijks functioneren taken. Beide groepen verbeterden toen wel over de tijd, waarschijnlijk door de training zelf. Concluderend. In deel 1 introduceerden we een innovatieve methode om behandelopties eerst te evalueren bij gezonde vrijwilligers. Hoofdstuk 2 laat zien dat de parietale cortex een bredere rol speelt in aandacht dan eerder gedacht. In hoofdstuk 3 concluderen we dat, hoewel TACS de aandacht niet verbetert bij virtuele neglectpatiënten, de hersenrespons sterk afhankelijk is van voorgaande stimulatie. In deel 2 onderzochten we of alpha-TSCS neglectsymptomen bij echte patiënten kan verminderen. In hoofdstuk 4 levert dan het eerste klinische bewijs dat TACS mogelijk de ruimtelijke aandacht bij subacute beroertepatiënten kan herstellen. In hoofdstukken 5 en 6 concluderen we dat multisessie TACS gecombineerd met revalidatie tot langdurigere verbeteringen leidt dan training alleen bij chronische patiënten. Toekomstige studies zouden TACS moeten combineren met realistischere training om het herstel in dagelijks functioneren beter te ondersteunen. Daarnaast is systematisch onderzoek nodig naar factoren die de behandelrespons beïnvloeden, gezien de grote variatie die we zien ook in eerdere studies. En deze kennis zou kunnen helpen om TACS-protocollen beter af te stemmen op het individu, met als doel de effectiviteit te verhogen en duurzaam herstel te bevorderen bij mensen na een beroerte. Dank u voor uw aandacht en ik geef graag het woord terug aan de prorector.
Yeah. Thanks a lot, dear candidate, for this very clear and timely presentation of your work. We now open the opposition, and I kindly ask Professor Milene Bonte to start. Milene Bonte is expert in cognitive neuroscience of language and literacy development. Milene.
Thank you, Prorector. First of all, I would like to congratulate the candidate and of course also her supervisory team with this interesting thesis and great achievement. And I very much enjoyed reading the thesis. It's really a different field, but I very much, from my own expertise, I really enjoyed it. And what I particularly liked about your thesis is the focus on both multiple aspects of attention, right, as you explained also in your presentation, and also the use of non-invasive brain stimulation and EEG, both from a fundamental scientific point of view and also from a clinical perspective. And your thesis also highlights several challenges then in translating actually these scientific findings to clinical practice. Including, for example, challenges due to variability because of state dependence of the stimulation effect, and also because of individual variability in, for example, symptoms and in general brain networks, right, between individuals. And then in your discussion, you describe or you propose that personalization of the approach rather than a group-based approach could maybe improve treatment effects. And so actually my first question would be really general in the sense that if you were given a nice sum of money, what aspect of, for research, what aspect of individual variability would you target in your study, so to improve treatment and get to this personalization?
Highly esteemed opponent, thank you very much for your compliments in your question. So yes, indeed, there is a lot of variability. So in literature, we also read about this variability a lot. So there's intervariability, intravariability. Yeah, I think it's really important that we systematically also tackle this problem. So I think if we would get a lot of money and use it for research, yeah, I think so it's good that we then focus on really seeing where this variability then comes from. So we can look at either different subtypes of patients. So there are so many types of neglect patients. It's a syndrome, so there is a lot of deficits, lateralized attention deficits, but also maybe sustained attention deficits. Maybe there's so much going on in the brain of patients, of course. It's, the lesion can be different in size. It can be a different location of the lesion in the brain. But symptoms do not always reflect, I think, the location of the deficit or even how large the deficit is. Maybe we should go back to a more basic, like the underlying problem is, I think, the asymmetry in alpha power between the two hemispheres. So I think if we would get a lot of money, we should use it to measure EEG in patients, and based on this, decide is there like a big distortion of this EEG, of the alpha power lateralization, because I think this is the root cause of their trouble.
Yeah, and then because you mentioned also in your discussion that you actually already also did measure EEG, right, in the patient. So it's not included in the thesis, but you have collected these data. So did you have a look at this data or also?
Yeah, we are working on it indeed. Yes.
And do these data give you some of the hints that now you spoke about? So do you see indeed that, for example, do you see variability in alpha power and or?
Yeah, I think it is a very it's a very good question, because you see different things also in literature. So with resting state EEG, sometimes you see that alpha power is actually enhanced in the right hemisphere. But this may depend on whether you measure this during a task or maybe in resting state, so eyes open, eyes closed sort of measurements. We see in our data that the left hemisphere actually shows an enhanced alpha power during rest, resting state EEG. We think this might be because the right hemisphere is damaged, so it has a reduced excitability. Also, alpha power is reduced, and then the other hemisphere gets overexcited, and also the alpha power can get overexcited. That's now what we think, so it's an hypothesis. Yeah. But yes, there is variability. I also have, so we have hypotheses about how the stroke then affects resting state EEG. So we have, so the idea behind our work here is, of course, we stimulate the left hemisphere, because during attention in healthy participants, we see that attention can be modulated via this lateralization of alpha power. That's what we base our research on. But yes, so I think looking at how this then is changed in patients can really give good insight as well. But because of this variability, it's really hard to really put the finger on what's really happening. I think the model that we have is already a great way to base our research on, so to say. Okay, very clear. Thanks.
Thank you, Professor Bonte. I pass the word on to Professor Arjan Blokland, expert in comparative neuroscience at Maastricht University. Arjan.
Thank you, Mr. Rector. Dear candidate, also my congratulations for this very nice thesis. Of course, your supervisory team will help you through this very long trajectory of hard work. And I would like to commend you for all the effort you put in this, considering all the things that happened along the way, also privately. Really well done. And also, the thesis is really nice. I also had much pleasure reading the whole thing, and especially, and even pages 199 to 204, really interesting. But of course, I'm also here to ask you some questions. You're now looking to page 199?
Yeah, I want to see what this is. Wow, okay.
Yeah, very interesting, yeah. We talk about alpha power and theta power, and that should be kind of the balance in the brain that leads to this in these stroke patients, or even in the induced stroke patients of healthy volunteers, actually. And it seems as if you just have more theta power, then you can have neglect on the contralateral side. And if you increase the theta and the power is moving to alpha, then it is restored again. That seems to be the simple conclusion of this thesis. But I mean, for me, it's quite really difficult to understand that if you just stimulate the brain, and then if you just move it back to the alpha power, then your neglect is gone, well, more or less. So that would mean that you just, anything that stimulates the brain, and for me, the brain is much more complex than just changing the rhythm, and then we're in good shape again. We can see what's in both sides in my hemifield. So how can you explain to me, because I'm not so well informed on this whole topic, but just simply theta alpha explains the whole neglect. Can you explain that to me?
Highly esteemed opponents, thank you very much for your compliments and also the question. Yeah, so indeed, it's a very complex cognitive function, attention. And I think in science, we try to reduce the complexity and try to figure out, looking at a complex issue step by step, how it works. So attention also is so much. So we have orienting, we have alerting, we have executive, but there are, I think, more attention, like attention functions than we are studying here. So in this paradigm of attention research, we focus on these three, at least in the healthy participant studies. We base it on previous research. So we know that the alpha oscillatory activity is really related to attention, orienting of attention. But
yeah,
we
okay,
know
but the point I would like to make, maybe to make it myself maybe more clear, is that so anything that I could use, so when I have my own brain, when my brain is modulating alpha and theta, maybe that I understand, but if anything that just affecting the brain activity, so more synchronization, so with alpha, anything you do that would increase the ability of the brain, is it that simple?
So it's brain plasticity, of course, that we are trying to enhance with brain stimulation. Yeah, so it really tries to get the neurons fire in this rhythm of the alpha rhythm. So from indeed outside the brain, we can manipulate the activity inside the brain. So we try to bias the spike timing because we are elevating the membrane potential of the neurons, and then it naturally, so the naturally occurring spiking then biases towards these phases of the alpha rhythm, and that way we can enhance attention. Okay. So it is not only associated with attention, but we actually see via this work, but also so much previous studies, that it is causally also related to attention. Okay. So it is really...
Yeah, I would like to have another question before my time is up. Yeah. If I am, so but you like to philosophize with your husband about things, and things that really I read everything. Yes. So the author, and it seems like that is this attention or awareness, maybe consciousness, or is it something like sensory discrimination? What do you think this alpha is related to?
Yeah. So also neglect. Like, what is neglect? It's also a very complex thing. Disorder, syndrome. Also, you can define neglect as being a deficit, a loss of function. It can be a severely biased competition between hemispheres. It can even be a disengagement. It can also be like an awareness deficit. So their awareness.
What do you think it is then?
So I may be biased. So I think we can stimulate with TACS. We know that this alpha is related and even causally linked to attention. So I think it has to do with attention.
Okay.
And from previous studies, we also know, or we think, that the more frontal regions are can be explained by one theory, and the more posterior regions can be explained by another theory.
Okay.
So there are many puzzles, pieces of the puzzle together form a puzzle. I think we're not yet there, obviously, but that's science. We're building and working on it.
Thank you very much for your answers. I'll give the word back to the rector.
Thank you, Professor Blokland. I pass on the word now to Professor Monica Harway, expert in neuropsychology and cognitive neuroscience at the School of Psychology and Neuroscience, University of Glasgow in the UK. Monica, you have the word.
Yeah, first of all, my congratulations on that thesis. It is a very large, very comprehensive piece of work, and you really did a lot of really novel work, both in terms of the stimulation that you're using in the healthy participants and also in the patients, and kind of doing that transfer from the design that you have in the healthy population and using TMS and then TACS, combining that and getting that to kind of inform the patient trials. So this is really very impressive work, which is also borne out by the fact that you already have multiple publications and you're also still doing more work. So well done. Congratulations on that. I have a sort of slightly different question, and again, sort of coming more from the neglect angle, because the first two experiments that you did when you were effectively using kind of TMS, to sort of bias performance, you managed to do that really quite well, for the alerting task and also for the executive function. But you didn't really manage to bias performance more in the orienting task. And don't you think that that is a little bit problematic, because you were then using that to inform, the neglect interventions? I would just like to have your thoughts on that in the first instance.
Highly esteemed opponent, thank you very much for the compliments and the question. So let me get this straight. So the sound is not always very clear. I think if I understood you correctly, you're asking why it is that we find no effects on the orienting aspect of attention, whereas, well, we obviously find effects on the executive control and alerting. And if this has then, if it's problematic for the then therapy of TACS afterwards. So that's chapter 3, right? Yes. So indeed, we did not find these effects on orienting. We think this also has to do with the task, really. So the task was very, it asked a lot of like sustained attention from the participants, because we had these lateralized targets that were also then flanked with these other arrows. So it really placed a lot of demand from the participants. This is different from like classical orienting paradigms that are used in literature. So there are no flankers above and below the arrow. Maybe the classical Posner task is it is really different from what we used here in our research. So for the orienting, that's probably why, and also there is variability in TMS effect. That's also what we discussed just before. So I think also what we see in chapter 3, when we look at the EEG, the resting state EEG, there is not a group effect of theta-lateralization. So that might also be a reason that we do not find effects on the behavioral orienting. To move on to your next question, is it problematic for treating the virtual patient? I think not. I mean, of course, we cannot treat the deficit if it's not there. So that is, of course, then what we are just disregarding for now. But we can treat, of course, the other two aspects of attention. So the whole gist of the study is indeed to see the task specificity of TMS and TACS as well. So we also try to figure out whether stimulating then the contralesional hemisphere would improve then the deficits on alerting and executive control, which it did not.
Yeah, thank you very much. And again, just to kind of follow on from that, because you're right, and I think you hinted at this a little bit, so maybe with hindsight, it might have been slightly better to use a slightly different task. And I was thinking, because then when it comes to your neglect intervention and the bigger study, you had like a line dissection task. And I can see that that is maybe difficult to actually use in the contents on healthy participants and the TMS intervention because you have the motor components, that's... But you might have wanted to look at something like a landmark task, which is a purely perceptual task. So that might have sort of led to nicer effects. So that's one of the ways you could have gone. And then you already elaborate a little bit on how you might have just played around, with the tucks and what you can do to make that more sensitive to individual participants. So those are really nice answers. So then just more generally, because I think it is very impressive that you kind of really found these sort of alpha tax effect in neglect patients. And as you know, some other people, it's very difficult to find these effects. So it's very laudable that you did. And you had a really nice randomized control study. You published the protocol. I think that's a really nice thing to do. So then just in terms of, and you were quite honest also, and a lot of studies don't have this on the feasibility. So ultimately, you only managed to kind of randomize, 18% of neglect patients who were eligible. And you then did have some nice effects, but you didn't really, again, have an effect sort of on the more sort of spatial line dissection task. You didn't have an effect on activities of daily living. So I'm just wondering, would you then sort of run a phase 2 trial, like a bigger trial with this kind of data? I mean, what is your feeling just overall in the wider picture of using it more generally for neglect intervention? Would you be kind of for that, or would you say, well, maybe, it's maybe not quite there yet?
So if I understand correctly, you are asking, so the generalizability of this study is quite low. That's correct. And you are asking if we would broaden maybe like the inclusion criteria, we could have a higher generalizability. Is that? And then maybe we could find
No,
effects.
I think my question is more, given that your feasibility is relatively low, if you were to do a larger study, say phase 2 trial, where you would kind of, run this on hundreds of participants, do you think that's the way to go, given that you're only able to kind of, randomize 18% of eligible patients, into the trial?
So we did a power calculation beforehand, of course. So it was probably, it was based on, of course, the primary outcome measure for the daily activity measures. So it was, of course, secondary to our study. So I don't know whether really like having a larger sample size would be the way to go. I think we should look more into other ways of training. So our visual scanning training was really like on a tiny screen. This could be improved maybe with virtual reality or augmented reality. So maybe we should move more towards training really in a more ecological way, so in a more realistic also environment. And then I think that's more the way to go to find effects on this daily living.
Okay, that's great. Thank you very much. That's the question.
I have to interfere and stop you here, and I hope that later you find a way to discuss this further. I pass on the word now to Professor Dr. Anne Fischer-Meili, expert in rehabilitation medicine at the UMC in Utrecht, the Netherlands. Professor Fischer-Meili, you have the word.
Thank you, Rector. Dear candidate, you have done important work by increasing basic knowledge about neglect and by conducting clinical studies with non-invasive brain stimulation. Clinical studies are very difficult. There are always many bumps in the road, so therefore my compliments for all the work, and I would also like to express my compliments to all your supervisors. I would like to discuss the clinical part of your thesis. And my first question is about proposition 9 of this thesis. Would you or one of your paronyms read this proposition aloud?
Proposition 9. In the chronic phase after stroke, cognitive rehabilitation should go beyond compensation and incorporate strategies like non-invasive brain stimulation, which directly target the biological basis of stroke-related impairments.
Thank you. Where does this proposition come from? It is not a proposition. Is it a wish or is this knowledge?
Highly esteemed opponent, thank you very much for your compliments and also your question about the proposition, which I really like. So I hope it's based on knowledge. It doesn't say this thesis after the proposition, but it could have been, because I think what we show also in this research is that the stimulation and the training together really led to enhanced effects of the training itself. So both groups received the training. One of the groups then additionally received the stimulation. And what we think happens then when combining the stimulation and the training is that the TACS can then enhance neuroplasticity, making it like priming the brain that that an additional treatment that is also brain-based, so also visual scanning training, also of course affects the cognitive functioning, that this then gets further enhanced so that it has a cumulative effect. So these two strategies will then further enhance the intervention effects. So I think that cognitive rehabilitation could really benefit from having also these types of brain stimulation in combination with training that is usually more compensation like. So combining it maybe with a more brain-based enhancing neuroplasticity can then also really help like finding effects of the other therapy.
I understand this, but I'm really surprised about the word chronic in your proposition. Why did you use the word chronic, and do you have knowledge about that?
Yeah, so we went to chronic patients in chapters 5 and 6. So this was really a study in chronic patients. Really, even years after the stroke, patients still have these problems. They were really excited to also participate in this study. And they
do you think that renders plasticity?
What? Excuse me, what did you say?
Chronic phase and plasticity. The word the chronic phase, most of the time there is not much plasticity in the brain. So that was my surprise. So
we do find effects in chapter 6, quite strong interactions. So that is the stimulation and hemifield interaction that we find. I think it's really obviously in there that we find enhanced effects when we stimulate additionally to the training only. Yeah, so based on the research, I think we really have shown that the brain is plastic also in this chronic stage.
Yeah, so it's not a wish, but knowledge. Then my second question is about transferring treatment effects to daily life. And I would like to discuss this issue following chapter 6. In order to understand whether there are transferring treatment effects to daily life, it is necessary to know more about study group. And in table 1, you describe the characteristic of this group, but I miss a lot of characteristics. These patients were chronic, living at home, but I do not see data on ADL, independence, hobbies, use of bicycle, public transport, etc. Can you describe this group more in this way?
Yeah, so I think in the chronic phase, it's a different story than in the subacute phase, because indeed in the subacute literature, stroke literature, there are more characteristics that describe the patients. So we don't have those. So that's because we came into contact with the patients also through sometimes the subacute center, rehabilitation center, and then we just came home to them, and that was all we had. So we did not also ask for additional variables, information about these patients, no.
But why didn't you do that? Because if you would like find a fact, it would be on participation level, isn't it?
So I think indeed this can be very relevant. We also included like time post-stroke in the analysis, so and age and gender, and indeed sometimes this affected also the effects that we find. So you can see that in table 2, that sometimes, for example, gender is a significant covariate. Also times, yeah, we also include time post-stroke. Making different subgroups, for example, is I think a next step. So we wanted to see if TACS could work, if we want to see if it really helps. So also looking into effects of daily living, participation, then I think indeed we should look also at other things that matter, also based on the ICF model. I agree fully with you that it's not just about brain-based variables that matter. It's also, of course, level of participation that could help the coping strategies that patients have or don't have. So yes, I think also of course, in therapy, these are very important to get the patient also participating and getting along also in activities.
Thank you. And given the time, I again have to interrupt this nice discussion. Yeah. Thanks a lot, Professor Fischer-Smiley. I would like to give the word now to Professor Werner Mess, expert in clinical neurophysiology here at the Medical Center in Maastricht. Werner.
Yeah, thank you, dear candidate. First of all, of course, I would like to congratulate you and the team with the work you have been doing. And I really learned a lot. And it actually remembered me at my time as a resident. And there were some people there, some neurologists, and they were educated by Richard Jung, one of the neurologists that built up neurology after the Second World War in Germany again. And he was very fond of neglect, and he had a huge collection of paintings of artists with a neglect, so very impressive. So let's stay with the patients when it comes to my question. So you have two parts, okay? So the theoretical part and the patient part. So when you go to the results, and then let's have a look at the results of these tests. What's actually the name? A cancellation test and visual detection test. Okay, were the results the same for the first part and the second part? Was it always successful? Was it an improvement when the patient did the tests or the subjects after treating with TACS? Short answer. Very simple question.
Highly esteemed opponent, I would like to thank you for your compliment and also your question. Short answer back? Yes.
Well, reading your discussion, the answer should have been no, because there was quite a success with the patient, but it could not be shown in the participants who had the TMS treatment. This is at least what I understand from your study, and I think this is completely understandable, because assuming that no is the right answer, okay, let's just do that. What might be the explanation for that? Why would the result be different?
So what results are you comparing exactly? I don't.
It's actually these tests we already have been talking about. And in the discussion you explained, you didn't find any difference in the subjects you treated also with TMS. That's the first part of your study. But you did find results or a change in the real patients with a stroke. So my question is, how does it come that you get such a different result? You get my
Yes,
point?
I think so. So we treated the TMS-induced patients, also with TACS, indeed, like we did also in the patients. So the patients, they were, of course, not stimulated with TMS before.
Okay.
So that's probably the difference between the two parts. So
Yes, of course, because
Yeah.
the patients are patients because there is something else going on. So talking about your patients, you can have a look at page 168. There is a table with the characteristics. As far as I can see, all read a right-sided lesion, right? Okay, of course, I understand why that is the case. But what about the patient characteristics? I couldn't find anything about the extent of the stroke, for example. You even have 7 hemorrhages, even subarachnoid hemorrhage, which is quite a diffuse lesion. So is the parietal model with the TMS really a good model for the actual patient with all the differences in stroke extent?
yes, so there is, of course, a big difference between stroke patients and research in stroke versus stimulating with TMS or TACS in healthy
But
participants. That
you
is
have not
indeed
so
my
many
point.
patients in your study, but could you see any relationship between, example given, the extent of a stroke and the successfulness of your TACS stimulation? Did you
The
see that?
The extent of the TACS, no. So,
No, so
of course, we had different tests, right? So, in the first half of the thesis, it's the LENT that we use. In the other half, we used more tests that are, in fact, closer to the deficit. So, to also for patients, tasks that are easily to do, that don't take up so long. Like the LNT is really 40 minutes testing. So I think it's okay to use TMS in the healthy participants. We've done it a lot. We've seen that attention also then gets impaired after TMS in healthy participants, and also we know also it's not just a focal lesion that we try to make, but it's also a network-based approach, because we know that when we put energy in one node, it also propagates to
I
other
think this
areas
is
of the
very
network.
important. You also showed that in your presentation. Of course, you have to go somewhere with your TMS, and of course, it makes total sense to go for the posterior parietal region, but you showed it's actually a network, and probably the complexity of the stroke patient reflects that you have different parts of the network that are involved. So, actually, your presentation already answered my question. Thanks a lot for your answers. I give back the words to the prorector.
Thank you very
Thank
much, Professor Mess. I pass on the word to Dr. Felix Tucker, expert in TMS methodology here at Maastricht University. Felix.
Yes, thank you. Dear candidate, Marij, also congratulations from my side. From my perspective, you've done one of the most difficult things one can try in our field, an actual RCT. So I'm very impressed.
Thank you.
And I would also like to ask questions about the RCT, in particular about the C, the control part. You know that I'm fond of control conditions and discussions about this, so I have a few points, let's say, that I would like to discuss with you. You caught me a bit by surprise on various occasions throughout your thesis, and page 179 is an example. You don't have to look it up. I'll read it out to you. You write, TACS does not generate audible signals, fair enough, and somatosensory sensations during active stimulation. And I thought, well, is that really true? And you provide a nice reference, Hermann in 2013, and I went to that paper and I looked it up, and they write something that is ever so slightly different, but in my view important. They say TACS can be applied in the absence of somatosensory sensations. And then they elaborate that you can actually threshold the stimulation intensity in such a way that it's not perceptible to the participant or patient. Well, this difference matters to me, and I wonder how much it matters to you. So I would like to invite you to talk a little bit about your control approach, because you didn't individualize stimulation intensity. So I would first like to hear your thoughts why you picked the control condition that you did, because as you know, there are different options. So maybe explain a bit your rationale for the active versus sham choice, and then we take it from there.
Yes. Well, esteemed opponent, thank you very much for your wonderful compliments and also your question. Yeah, so we chose a control condition that for the TACS, right? That indeed gives perhaps a little bit of somatosensory effects, because we ramp up and ramp down the stimulation. So that can be felt. It can be felt indeed. I know from also the first part of the thesis, when we were really testing a lot and a lot also of students, many don't notice that they even get stimulated. Like, it was very boring. Like the TACS, nothing, you don't feel anything, no side effects. So yeah. When there was sometimes an occasion that someone said, ouch, that really hurts, we would take it off and we would check if there were no injuries or like little wounds or anything that maybe all the current went into one place. So that was what we always controlled for, of course, also before we stimulated. Yes, yeah. that was our control, yes.
But so, I have this lingering thought then, right? There might be patients in your sample that actually feel this tingling on the left side of their head. And then I think, well, left side tingling, left side neglect, maybe this draws the attention to that side.
Yes, but
so it makes me a little bit uneasy in a way. So I wonder a little bit whether there are additional things you could have done, let's say, to maybe make it stronger or to convince yourself that this is a non-issue.
Yeah, so maybe I should also say that in comparison to TMS, these somatosensory effects are, of course, like NIU. Like TMS really gives these clicking sounds and somatosensory effects. But then, so if you think about active TMS, also gives maybe this tingling then. So in fact, wouldn't it be a good control? Because then you would have the same somatosensory effects.
But in active TACS, you would feel the tingling, and sham, it would be there initially.
Yeah, and with the sham, we do actually want it to really like be well compared to the actual TACS. So it would be a good thing that sometimes they would feel, when it is turned on, the somatosensory effect.
But you would agree that this tingliness ideally would be identical in both conditions for the full 40 minutes?
Yes. But it's only a little part of the stimulation that it's on. They also don't know the difference because you're either in an active group or in the control group. They don't know what this feeling would be if they would be in an active group. So okay. I think it's already...
No, I understand.
They're ignorant, right? Because they don't know better. Yeah.
Okay, fair. I also think it's a tricky thing in a way. But I wonder, in a way, whether you maybe could have included some questionnaire data or so. Let patients rate the sensations that they experience during stimulation.
It has
also
been done,
maybe about blinding success. So what, I know that this has been done in other studies, obviously, but you never know what happens in your context, in your sample. So I wonder whether there was a deliberate choice not to evaluate those things, like the sensations and blinding success.
I think we had already really a lot that we wanted to know. So for the patients, it was enough. Like all the questionnaires, and it was quite intense as it was. Also the EEG part, which we haven't even discussed here because it's not included in the thesis, but also even asking those things. We could have done it, of course. It would have been nice to have the data, but I think the questions we had were quite enough.
Okay. But in your mind, it's a minor thing, and we can probably forget about it.
I hope so.
Okay, cool. I think I have a minute left. Also about the same RCT. You write that you expected to achieve a synergistic effect in which TACS strengthens the efficacy of your visual scanning training. I simply wondered, couldn't it also be the other way around? Couldn't maybe the scanning training facilitate the TACS effect? And
yes, also sorry.
How do you conceptualize this?
Yes, I think it works both ways. So also the TACS effects depend on the brain state. So when we have participants being actively engaged in a task, this also helps the TACS to work better.
Yeah, but which one is it?
Both, I think.
Both?
I think so, yes.
How do you know?
We don't know, but if you think about it logically, I think TACS is really state dependent. We know this from previous literature. I'm distracted.
Always happens. Thank you. Thank you very much. I return the word.
If you like.
I think it works both ways, but we can discuss it afterwards.
Nice answer. Thanks a lot. Willemijn Middag van Spanje, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. And I kindly ask you and the company to await our deliberation. We return to this chamber for sure soon. Thank you.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Southside, 10 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. All your time, 'cause I'll go the extra mile. Long road to the south side, 10 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Get the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. Even though these nights seem long, I know that I am never on my own. Know you've won the battle once you've grown. Southside, 10 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. Long road to the south side, 10 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. Years can't fly by now, don't waste all your time. 'Cause I'll go the extra mile.
Also, welcome, nice to have the kids there. Hi. Willemijn Middag van Spanje. The degree committee here present has assessed the quality of your thesis and your defense in view of its positive verdict and taken into account your previous qualifications. The degree committee has decided to grant you the degree of doctor. Professor Schumann is authorized to confer upon you this academic distinction in accordance with the Dutch university custom. I kindly invite you, Theresa, now to take the word.
Belooft u dat u altijd volgens de beginselen van wetenschappelijke integriteit te werk zult gaan, eerlijk en zorgvuldig, transparant, onafhankelijk en verantwoordelijk?
Ja, dat beloof ik.
Geachtens de bevoegdheid ons door de wet toegekend, volgens het besluit van de commissie hier tegenwoordig, verklaar ik u hierbij, sorry, dat is een moeilijke naam, Willemijn Bertine Miriam Middag van Spanje, Marij, tot dokter te bevorderen en u alle rechten te verlenen die daaraan volgens wet en gewoonte zijn verbonden. Ten bewijze hiervan overhandig ik u nu de bul, door rector, secretaris en overige leden van de promotiecommissie ondertekend en met het grootzegel van de universiteit bevestigd. Dokter Middag van Spanje. Jij mag gaan zitten, als u wilt. Van harte gefeliciteerd. Wat een dag. Voor jou natuurlijk, maar ook een beetje voor mij. Je bent mijn 10e promovendus en de eerste aan wie ik zelf de bul mag overhandigen. En ik kan me werkelijk niemand beter voorstellen hiervoor dan jou. Nou, laudatio's die beginnen vaak met een blik terug in de tijd. Dus ik neem je mee naar, volgens mij was het al 2016. Ja? Toen besloten ze bij Interact Contour, voor die mensen die het niet weten, een organisatie die mensen met niet aangeboren hersenletsel begeleidt, dat ze niet alleen goede zorg wilden leveren, maar ook willen investeren in onderzoek. En ze hadden jou, Marij, op het oog voor een promotietraject. Samen met Jaap van der Pol, die hopelijk ook vandaag hier zit in het publiek, fijn, ben je begonnen aan een soort universitaire roadtrip. Jullie spraken met verschillende groepen op verschillende universiteiten. Ik herinner me nog precies eraan hoe jullie met z'n tweeën, jij en Jaap, op Alex en kamer zaten en we onze eerste ontmoeting hadden. Toen je klaar was met je roadtrip, kregen we te horen, jullie kiezen voor Maastricht University. Jullie kiezen voor Alex, Caroline en mij. En eerlijk gezegd waren wij heel blij mee. Dus bij deze alvast heel erg bedankt aan Interact Contour voor het vertrouwen dat ze in ons hebben gezet. Nou, al vanaf het begin werd duidelijk dat jij een heel bijzondere promovenda zou zijn. Je maakte een flinke overstap van public health naar cognitieve neurowetenschappen en neuropsychologie. Oscillaties, of zoals jij graag zegt, oscillaties, hersenstimulaties, labs, METC-aanvragen, het was allemaal nieuw. Maar jij raakte niet in paniek. Jij ging gewoon aan de slag. Met rust, met overzicht en met duidelijke vragen. Je gaf heel duidelijk aan waar je hulp nodig had en wanneer je liever iets zelf wilde uitzoeken. Je verhuisde niet naar Maastricht, maar je was er wel vaak, met name in het begin. Volgens mij bleef je vaak in een bed and breakfast in het begin en na een tijdje bij Charlie, die vandaag je paranimf is. Nou, zoals jullie vandaag hebben gehoord, je werkte eerst aan een studie bij gezonde proefpersonen, waarin we met hersenstimulatie virtuele patiënten probeerden te creëren, die we vervolgens konden behandelen. Alles liep super. Je verzamelde mooie data, hield overzicht en het ging allemaal volgens plan. Maar zoals dat gaat met plannen, die lopen uit de hand. Gelukkig in de goede zin, want we wilden natuurlijk verder. Niet alleen experimenten in het lab, maar echte impact. Dus we gingen naar de kliniek. Wij ontwierpen, nu ook samen met Tanja Nijboer, een intensief behandelprotocol voor patiënten met chronische neglect. En toen begon het echte werk. METC aanvragen, patiënten werven, samenwerking met revalidatiecentra opzetten. En hier kwamen jouw sterktes nog veel duidelijker tot voorschijn. Tijdens deze studie werd duidelijk hoe ontzettend goed georganiseerd jij bent, hoe goed je communiceert en wat een fijne collega je bent om mee samen te werken. Want dit was een megaproject. Patiënten 3 keer per week behandelen, 6 weken lang, verspreid door echt het hele land. Stagiairs begeleiden, en je had er heel veel, en trainen, apparaten sjouwen en alles regelen. En dat alles met een glimlach en een Excel-sheet die altijd klopte. We hadden veel meetings, veel WhatsApp-contact en af en toe kreeg ik een telefoontje. Theresa, ik heb gel nodig of ik heb stickers nodig. Nota bene ergens in Groningen of daar in de buurt. Gelukkig hadden we ook Jeannette, die wat centraal in het land woonde. Dus ik gaf het aan Jeannette mee en jij ging naar Jeannette toe. Zo hoefde niet helemaal naar het zuiden te rijden. En zo ontstond een informeel netwerk van wetenschap in beweging. Jij in het noorden, Jeannette ergens halverwege en wij in Maastricht. Dus ik denk dat jullie een goed gevoel hebben gekregen wat een mega-organisatie dit project was. En dan heb ik het nog niet eens gehad over de echte problemen die Marij meemaakte tijdens dit project. De studie loopt, alles functioneert en plotseling slaat corona toe. Revalidatiecentra gingen dicht voor buitenstaanden, patiënten werden ziek, alles lag stil. Onderzoek met kwetsbare groepen bijna niet te doen in die tijd. En toch lukte het Marij om uiteindelijk weer met hele duidelijke hygiëneprotocollen en regels door te mogen gaan met de studie. Dat is fantastisch. Corona was het ene probleem, maar in Marij's privéleven speelde zich ook van alles af, wat natuurlijk geen probleem was, maar wel heel veel van jou vroeg. Zoals jullie zien, Marij heeft tijdens haar promotie 3 kinderen gekregen. David, Manuel en Pablo. Ik weet dat hier veel mensen in het publiek zitten of online die het al zwaar vinden om een PhD-project te doen. Stel je voor dat met 3 zwangerschappen en dan nog 3 kinderen daarbij te doen. Maar ik ben zo onder de indruk van jou dat je dit hebt volgehouden en dat het je gelukt is. Want ook met die kinderen erbij, jij bleef altijd leveren, deadlines, analyses, manuscripten, alles op tijd. Je bleef betrokken, ook als het druk was. Je begeleidde je stagiaires met aandacht en je dacht mee met anderen. En kijk wat een mooie proefschrift je nu hebt. Een van de eerste klinische TACS-studies überhaupt. Niet alleen in Nederland, maar echt überhaupt. Je bent inmiddels weer terug bij Interact Contour en ik hoop dat we samen doorgaan. Dat we hersenstimulatie echt in de revalidatiepraktijk kunnen brengen. Zoals jij zelf schreef in jouw laudatio, it takes a village. Caroline, Alex en ik zijn blij dat wij de laatste jaren deel mochten maken van jouw village. We hebben intens genoten van deze samenwerking. En dan wil ik natuurlijk ook nog de familie feliciteren, Martijn en de 3 jongens, David, Manuel en Pablo. En natuurlijk ook de ouders en de rest van je familie. Hoe bijzonder is het dat je vader vandaag letterlijk en figuurlijk achter jou stond. Van harte gefeliciteerd.
Thank you, and also on behalf of our rector and the dean of the Faculty of Psychology and Neuroscience, congratulations to you, your family, and your friends and colleagues. I think it's a team effort, but it's the individual who's in the sunshine today, and you should enjoy your time. I also thank the members of the Corona and the Reading Committee for all your work in preparing this session. Highly appreciated. I hereby close this academic session formally, and I kindly ask you all to actually already leave the aula after us already now, because we will take a picture here with the 2 colleagues online. We will also go to the stairs and take a picture with all, also family, if you like. If you want to have a staircase photo, then follow us to the stair. All else already go to the reception.